In this video from section 4.4 in MGF 1107, we are asked to do an operation in another base other than 10. In this case, we are asked to multiply in another base, and it happens to be base 9. Now, one thing we must remember when we're multiplying in base 9, that there are 9 symbols in base 9, and the 9 numerals will be 0, 1, 2, ... all the way up to 8. So 0 through 8 are numerals. If we wanted the number 9 in base 9, we have to remember the place values. If it is in base 9, the place values would be the 1's digit over on the right, which could be a 0 through 8. And then we have the 9's digit, like 9 to the first, to the left of that. And then 9 squared, that's a 2, 9 squared, or groups of 81 to the left of that, and then 9 to the third, which I believe is 729 to the left of that. So we have 0 through 8 as kind of like our 1's digits. And then if we wanted the number 9, what we would do is we would write one group of 9 and 0 1's. So after 8, we actually go 1, 0. And that's 9. That means one group of 9 and 0 1's. And then how we would write 10 is one group of 9 and 1 1. 9 plus 1 is how we would write 10 in base 10, and so on. The key thing is these are the basic digits or numerals. So in our specific problem here, we have to multiply through by 8 first. So 8 times 0 would be 0. 8 times 6. 8 times 6 is what we would say is 48 in base 10. But then to convert that to base 9, we have to convert it using these place values. And what we would do is we would say, well, which place values do we need? Well, we don't need the 9 squareds or 9 to the thirds because they're too big. 9 squared is 81, and we only have 48. So we're going to use the rightmost place values and say how many groups of 9, start with the largest place value. How many groups of 9 are there? Well, if you have 48, you have 5 groups of 9, because 5 times 9 is 45, and 3 1's. And then you only need those place values, so we can get rid of that place value over there. And that would be in base 9. So 48 in base 10 is 5 3 in base 9. So we write down the 1's digit, which is the 3, and we carry the 5. And then we go, well, what is 8 times 5 plus that other 5? Well, that would be 45. 8 times 5 is 40, plus the 5 we carried is 45. Well, 45 in base 10 is just 5 groups of 9, because remember these are the 9's and these are the 1's. 5 groups of 9 and 0 1's. So, because 5 times 9 is 45. So we'd write that, 0 and then 5. So that was multiplying through by the 8. In the 3 8, we multiplied first through by the 8. Now we have to come back and multiply through by the 3. So we move over a place value, and we start. It was 3 times 0 is 0. 3 times 6 is 18. That's 18 in our base 10. Well, 18 in base 10 would be 2 groups of 9 and 0 1's. So we divide by the 9, the place value of 9, and we get 2. That 18 has 2 groups of 9 in it with nothing left over, with 0 left over. So for that number in base 9, we write the right digit 0, and we carry the left digit of 2. So we're carrying the 2 now. So we have 3 times 5 is 15, plus that 2 is 17 in base 10. Well, if you have 17 in base 10, what is that in base 9? Well, how many 9's go into 17? Well, you have one group of 9 with 8 1's left over. So that's 8 and then a 1 and a 1. Let's see if I can write that 1 on the screen. I'll get it in there. And again, these are in base 9, and now we add. So 0 plus 0 is 0. 3 plus 0 is 3. 0 plus 0 is 0. 8 plus 5 is 13 in base 10, but 13 in base 10 is one group of 9 with 4 left over. Because 9 goes into 13 one time, and you have a remainder of 4. So you write down the right-hand digit and carry the left-hand digit of a 1. Carry the left-hand digit of 1. 1 plus 1 is 2. So I'll rewrite it. It's 2, 4, 0, 3, 0, and that's in base 9. And that's how we multiply in another base.